final amount. What was our final amount? That is 100. No, that was 25, right? So 25. Initial amount. So that is what we are seeing here, right? What would this? Okay, let me continue here. Okay, over here. So I have half n equals. What would this give us? 25 or 100 will give us one. What am I going to get? No, in fraction. That will be 1/4. No, in indices, you have this. Do you agree? In indices, you have this. Good. Do you agree? 2 squared is 4. And minus is there. So you compare. You have minus n equals -2, right? So what you see here is -1 n equals -2. So I'll divide through by -1, right? Positive n is this. I have 2. So how do I find the time with this? This is very simple, right? I can even do the half-life without even punching any calculator, because you see, it's true, it's real. That's a fraction left approach. Now, how do I find my time using the same fraction left? Now that is what you do. You go this way. If 2 half-lives equals the total half-life during was 1620, right? 1620 years. That's how you do it. If 2 half-lives. Okay, no, you are looking for the time. Okay, if you're looking for the time, it has to be the other way around, right? If you're looking for the time, it has to be the other way around, like this. If 1 half-life equals 1620 years, you see that? Then 2 half-lives will give me, I need a space to write. So 2 half-life, and clear this, we have them already. And 2 half-lives will give me 2. This and I remember the short proportion. So check this answer for me. Let's go. 3. Okay, so this is what we are getting here. 3240 years. Compare it to the first approach that we did, right? Using the formula. We got the same answer, 3240 years, right? So you see how simple fraction left approach is. Then it's formula free. So if you look at it well, you can even use I expression to just solve half-life question. Very simple. So that is the formula. So there's a fraction left approach, as you see. So we have the same answer when we use the formula. The formula was very lengthy, right? This is very short, very concise and precise as well, right? Okay, now let's look at another question. The first one that we did, we were looking for how long, that's the time. Now we are going to look for the half-life itself with the same fraction left formula. Let's see how we use the same formula and let's see how we manipulate them. Right. Let's go. A radioactive material of mass 80 grams decays to 10 grams in 6 years. Calculate its half-life. I don't want to go through the steps of using half-life 0.693 over K, natural log n naught over n equals kt, 2.303 log n naught over n equals kt. No, that's too much. So I want to just go straight here. Now let's go. From here, the mass is 80. So that is my initial amount, 80. Decays to 10. That should be what? The final amount. Let me quantify them well. So initial amount, that is n naught. Final amount, that is n. Good. So using the relation 1/2 n equals fraction left. So I'm going to use a fraction left approach, right? So let's go. I have 1/2 n here. That is final over initial. Remember? Now 1 over 2n final is 10, initial is 80. I'm going to get 1 over 2n, that's a subscript, superscript exponent, that is 1 over 8. Indices, I hope you agree. Indices, once again, that's 2 raised to the power 3. Indices, 2 raised to the power minus 3. So n will be positive 3 when you cross or you divide through by minus 1, right? I have 3 as my answer. I want half-life. So how do I manipulate this fraction left to get a half-life? The first one I did, when you want the time, then you say 1 half-life equals the half-life given in the question. Then you bring the value of the n. I'm getting n equals what? 3. So I'll go this way. But 3 half-lives equals 6 years. Then 1 half-life is going to give me 1 over 3 by 6 years. You're going to get what? 2 years. That is the answer. So easy. Now, how can you ascertain this? Try using the formula. I think you have to employ 2 or 3 formulas just to get this right. Use the formula, you still arrive at 2 years, right? Good. So that is the power of the fraction left approach. Thank you.